Hi all, this is Maniramakrishna. So in the previous lecture, we have discussed about the current density in the form of, that is, in the conduction, convection and displacement. Okay, so now the today class is about the continuity equation of the current. So here, before talking about the continuity equation of the current, so let's take the current. Okay, so current is the current. Okay, so current, if you take the current, so current passing through has the closed surface. Okay, so if suppose the current passing through the in a closed surface, that is equal to integral of surface into surface. Okay, so that is current density into surface area. We'll take in a closed. Okay, so current passing through in the closed surface. Okay, the current passing through in a closed surface, that will having the I is equal to, okay, the current I is equal to integral S J dot S. Okay, so this one. So if you take the as per conversion of law of charge, okay, so law of charge conversion of law, that is law of conversion of charge. Law of conversion of charge. So what will take that? So in the law of conversion of charge, so if you take that law of conversion charge, the net outcome, okay, so whatever the net outcome charge, the net outcome positive charge is must be balanced by, okay, is must be balanced by decreasing in the positive charge. So the net charge, okay, so the net outcome, so whatever the net is there, okay, the net outward positive charge, the net outcome positive charge must be balanced. So that will be balanced by decreasing in the positive charge. Okay, that will be in a decreasing. So that will be in a decreasing the positive charge in a closed surface. That is the law of conservation of charge. Okay, that indicates that I is equal to, okay, I is equal to integrals of surface into J dot S. Okay, so that is will take the if current. So in the closed surface, that is I is equal to integral of J dot S. That is current density in the surface. Okay, that is the closed surface we are taking. So if it apply, so from the law of conversion, so if you take that, that is minus, that is decreasing in the positive charge. Okay, decreasing the charge inside that one. Okay, whatever the outcomes are, that will be wasted. So here whatever did it, so here this one is called as the minus dq by dt. Okay, so whatever it comes, that is I is equal to minus dq by dt. So this one, okay, so all this one is called integral equation. Okay, so integral equation of, okay, integral form of continuity equation. Okay, this equation is called as an integral form of continuity equation. Integral form of continuity equation. Okay, so here if you take the divergence theorem, okay, so if you apply the divergence theorem, so what will happen? Let's check. Let's continue the equation, the continuity equation of the current. So here what we're talking about, the I is equal to integral the surface integral into J dot S. Okay, so here minus dq by dt. So now if you apply the according to the divergence theorem, okay, if you have by taking the according to the divergence theorem, so surface integral, okay, so surface integration, that is integration. Okay, so what we are doing, so we are so we are finding the here this equation is the integral form of the okay, so integral form of the current. Okay, so integral form continuity equation. Next we will take in the differential form of current equation. So from that here, according to the divergence theorem, that is whatever the current density is the closed surface, that is J dot ds. So if we take the divergence J dot into value, so here we are taking the surface, here taking the volume, so that is divergence of volume density. Okay, so that we are taking. So here due to this what will happen, so law of conversion, that is whatever the negative is there, okay, inside, so negative inside charge, that's q is the inside charge, that is negative is will take minus d by dq by dt. So we are taking the here from this one we are applying the, that is volume, so volume charge that will get, so rho v into dv. So here if we take this one, divergence theorem. So divergence of J into rho V. So we'll getting the minus di by dt. Okay, so if integral of, that is whatever the value is there, so we are applying here. So if we do the partial differentiation for this, we are getting the dou. Okay, so dou rho V by dou t by dv. Okay, this is for the here. So for the continuity equation of the current, so in the integral form as well as differential form. So this divergence J is equal to minus dou rho V by dou t is called as the differential form. Okay, this is the called as the differential form of continuity equation. Okay, this is called a differential form of continuity equation. So these are the two of the, that is, one is for the integral form of the continuity equation. Next, this is for the differential form of the continuity equation. Okay, this is about the equation of the related to the current conduction. Okay, so we are in the next we will talk about the convection as well as displacement. Okay, in the dielectrics. Okay, that we will talk about the in the current relation topics. Okay, thank you. This is Maniramakrishna signing off.